What commercial benefits does the Crux approach to simulation bring to a client?
I get asked to do all sorts of crazy things all the time. That's where simulation comes in. Some of the spiciest challenges, some of the biggest questions, just enough material to do exactly what it needs to. You're able to supercharge, accelerate, and de-risk earlier. That is where clients find most value.
Welcome back to the Crux Spotlight podcast series. Crux is a leading international design agency that designs products for a range of organisations, but always with a business focus. I'm Dominic Walters, an independent consultant, and in this series, my aim is to look at what makes great product design, and in particular, what makes Crux so good at it. One of the key aspects of the Crux approach is simulation, using simulation to help improve the design focus. And so this episode is looking at what Crux does around simulation. And to do that, I'm delighted to be joined by Max Dixon of the Applied Science team here at Crux. So Max, we're talking about simulation. What is simulation when it's referred to product design, and why is it so important?
Hi Dom. So I like to think of simulation as an umbrella term, and that umbrella term is used to define tools that help engineers or designers predict. And that helps them predict what happens if they want to make changes, or what happens if they decide to revise a design. Now, simulation can be used in a wide range of different contexts, and it can vary in complexity. A very simple example could be you might want to simulate what happens to your pension. As you add additional money into it, how is that going to grow? That might be a simple one. At the other end of that scale, when something's fully complex, you could have something like an aircraft wing. What happens as I change the shape? Will that produce lift? All of these things are driven by numerical tools or algorithms that you design the computer. And depending on the problem at hand, you'll pick one that suits you perfectly. In the engineering context, what we like to do is plan ahead. We like to be pragmatic and de-risk things as early on as we possibly can. The worst thing for us is to commit time, effort, and money, and then down the line, something's gone wrong that we haven't foreseen or haven't predicted. So we like to do dry runs, rehearsals, or simulate these scenarios, if you like. And for those types of things, we lean on technology, and that's where we might simulate on the computer. So we can lean on a wide range of different software packages to do this. But what they enable us to do is de-risk some of the choices that we might make, whether that's around the shape of a product, whether that's around the features of a product, whether that's around how we manufacture it. Simulation allows us to explore those spaces, explore a wide range of different options, explore that on the computer, where things are cheap, things are fast, and we're able to change a lot more of the knobs and dials and buttons that would be very expensive, very time-consuming, and very costly if we were to do it in the real world.
Right. You
wouldn't want to manufacture 30 different variants of the same product, because the time involved to design all of them, the time involved to make all of the molds, the time involved to manufacture all of them, the time involved to inspect all of them, the time involved to test all of them is quite large. But if you could do that all on the computer, then that accelerates that process, that de-risks it early, and it brings those insights into the hands of the designer really early on in that process. And that's really why we use simulation, to help de-risk products early.
Okay. So a lot of it is about speed, it's about making decisions earlier, and it's about, I guess, not committing huge amounts of resources to something that in the end may not work or may not do what you want it to. It's about helping that decision process, I guess.
Exactly. So speed is one thing. Once you've set these models up, you can begin to start asking them questions. And those questions can be, what happens if I change the material? What happens if I swap this part out for that part? What happens if I make this over here instead of over there? What happens if I make this component blue instead of red? And the model can very quickly give you those answers. To do those same types of questions in the real world, it can be very expensive and time consuming. And that's assuming you can even answer that question. Often there's so many other factors and variables to consider that you can't isolate specific things. But in the virtual world, where you do have control over everything, in the simulation environment, that's where you can begin to ask those questions.
Okay. I know it's apocryphal, but just a thought. I'm sure I read that Edison went through lots of iterations before perfecting the light bulb, and so had he had access to the materials and the systems you're talking about, that could have been a lot quicker. He could have saved himself some time.
I would like to think so. Yeah.
Okay.
So I would say simulation is a toolkit designed to complement other engineering skills. It's not designed as a replacement. It's designed to enhance and expand. So the effective use of this tool, or the effective use of simulation, is to use that in combination with physical testing, prototyping, your conventional engineering toolkits, you're designing, you're building and testing. By supplementing that with simulation, you're able to supercharge, accelerate and de-risk earlier at a level that you can't achieve with conventional testing alone.
Now, I know that simulation is one of the areas where Crux is ahead of the market, or a leading player in the market, and in particular because you've been applying it to FMCG and to pharmaceuticals, two areas where I don't think simulation has really been used before. So why are you so far ahead in this, and why are you doing it in those areas?
Yeah, that's a great question. I think fundamentally, the reason why those industries have been slow to adopt these tools has been from skepticism, which is arguably quite healthy, especially in the medical device space. There's a need to make sure the products that get developed work first time. They work every time because people's lives are at stake. And it's really important to make sure that they're able to get access to the healthcare products that they need. So therefore, there's been a need to demonstrate the validity of the tools, how appropriate they are, how accurate they are, and how robust they are. So a lot of work has been done recently around building toolkits or frameworks to help demonstrate that, to provide credibility to agencies like the FDA, for example, that might authorize products to come onto the medical market. So there's a healthy skepticism there, but that skepticism is slowly dissolving. And the people that I work with, the teams and my colleagues, we work around the clock to help sort of dissolve those barriers and help build the tools or the documentation required to support new products that emerge to the market that are developed with simulation. Now, these tools, I talk about simulation. There's a wide range of different ones. Different softwares do different things depending on the problem that you have at hand. But these aren't new. They're not novel. We're not rewriting the rule book in any way. These tools have existed for decades. And right now we sit on the benefit of being developed for decades. You wouldn't have ridden on a train. You wouldn't have flown in an aircraft. And you wouldn't have even bought a car that wasn't extensively designed on the computer, wouldn't have been developed with simulation.
Right.
But you wouldn't be able to say the same thing for a medical device, which I find really peculiar. I find it shocking, where an industry that's supposed to be high tech doesn't utilize cutting edge tools and technologies. So I find that quite interesting, and what we do here is help sort of shift that dynamic, encourage a paradigm shift in the way people view simulation within the medical device community, and that allows them to lean on those tools and rely on those tools and eventually get their products to market faster. Now, on the other side of that coin is the FMCG market, or the consumer goods market.
Yeah.
So these are all the things you might find in the supermarket. So your deodorant cans, your bleach bottles, your shampoos. Now, these are everyday products, so these are a lot more relatable. People use these day in and day out. And historically, they haven't required the use of simulation. It's been empirical. People's experience and judgment has led the design process.
Right.
But recently, there's been a trend to minimize some of the risks that they have in their industry, and they've looked to tools to help de-risk, and simulation is one of those tools. There's been a wide range of different factors that have driven that. One of the ones I like to think of is sustainability. People are a lot more conscious now. They want to use less materials. They want to use thinner walls, less plastic. They want to use recycled plastics. All of these have a consequence in terms of how the products perform. And in order to understand what they will look like or how they will react, they need to be able to predict that performance. So they lean on simulation as their prediction tool. Right. And that allows us as consumers to have products that are environmentally friendly. They're made of recycled products. We can put our plastics into the waste bin, knowing full well that the next generation of products have been designed to take those on board. The materials are recyclable, they're reusable, and it provides you with this this feel-good factor that you're not just throwing plastic away constantly.
Yes, I see. So looking at it from the point of view of your client or a potential client, what commercial benefits does the Crux approach to simulation bring to a client?
Yeah, that's another great question. So at Crux, we position ourselves quite uniquely as not only being simulation experts, but we also have an extensive amount of in-house testing capability.
Mm-hmm.
And the reason why that's important in the context of simulation is it allows us to validate our models. That means that we can pin them in reality and demonstrate that the tools that we're using are reflective of what happens in the real world. We're able to dissolve that barrier where people have a healthy skepticism around the virtual tools that we use. And Crux have that offering all under one roof. So we're able to develop these simulations or these digital tools. We're able to develop a test program to help demonstrate credibility. And therefore, then we're able to provide people with a robust and rich toolkit to help develop their products in the future.
Right.
And that really helps people develop their products faster, develops them cheaper, and at the end of the day, it makes them a more robust product. You're able to explore things in a way that you wouldn't be able to do with conventional tools. So it's back to that de-risking activity. It helps people identify where there might be certain combinations of things, where there's risk, and identify that early. And it's really, if I was to put it in a nutshell, I'd probably say it helps people pivot their mindset from being reactive to problems and risk to being proactive, where you can see things ahead of time, you can deal with them, you can resolve them, and it minimizes the cost to you.
Right. So rather than doing something and then realizing perhaps too late there's a problem and you have to go back and re-engineer it,
Exactly.
you can spot the problems in advance and plan that into your engineering approach or your design approach.
100%.
Okay.
And if you're, there's a spectrum, if you like, in the design process of where simulation can be deployed. It can be your partner all the way through, if you're going from an early stage of a product all the way through to mass manufacture or upscaling. And you can lean on the tools to have a digital twin, like a virtual replica, if you like. And that can show you what happens when we use a different supplier for a material or different color. We change tools, or we want to make 16 at once rather than 8 at once, and all these sorts of questions that an engineer will go through as they're designing. But you can also use it as a tool to help problem solve existing products as well. So if you've got an issue on the market and you're trying to understand what's going on, we've dealt with this problem for years now, we've banged our heads against the wall, we don't quite understand what's happening, and you've deployed every single tool in your arsenal. You've had engineers working on it for years, months, teams of 10, 20, 30 people, and all of a sudden someone comes along and says, have you tried simulating that? Have you tried controlling everything at once and isolating in specific variables that you're interested in and seeing if they are the ones that's causing the issue? You can turn down all the noise of the real world, all the variability that you expect from different people, different processes, different places, and really have this consistent, repeatable investigation, and you can identify exactly what's happening. And until you've realized that that's possible, until you realize that simulation is a tool that allows you to help supercharge and focus your investigation on specific things, you don't quite realize the additional insights that can be drawn from it. And being able to have those insights helps unlock a lot of problems that previously or conventional engineering tools would struggle with.
Right.
And that is where clients find most value, is that it helps unlock that next stage of their problems or their R&D programs where their known toolkits are struggling.
Okay. So if I understand that correctly, in traditional ways, problem solving was a little bit, and these are my words, hit and miss. You kept on trying things until you found perhaps what was the issue, what was the cause. Whereas with simulation, you can dial down things so you can focus on particular areas so you can get to the answer quicker.
Yeah, you could do it that way. The conventional approach would be leaning on your intuition.
Yep.
Say, okay, I think it's here, I think it's there, which is great. And I'm not suggesting that we don't do that. I think intuition is super valuable, and your gut instincts as an engineer are your sixth sense. You should always be leaning on those at any moment in time. But what simulation allows you to do in comparison to conventional tools, if we compare those two pipelines, conventionally you might say, I have got 3 designs I want to explore. And you might then 3D print those, manufacture them, test them all down in the lab, and then process that data. That's going to be time consuming and expensive. You've got to make sure that everything that's been manufactured has come out correctly. You've got to see, do the printers change depending on the day you printed it, the inks that come out. There's a variation that happens continuously all across life. When you do the same thing in the virtual environment, what happens is the only thing that you're going to change is the thing you want to change. Everything else is consistent.
Yes.
So that allows you to systematically say, this change has happened because of the thing I intended to change.
Yeah.
And you are able to draw conclusions a lot quicker and a lot faster. You'd be able to draw the same conclusions eventually if you had enough time, energy, and resources. But the simulation tools allow you to get there faster.
Right. So there's still a place for intuition.
Absolutely. I'm not advocating that at all in any way. I am an advocate of intuition.
But simulation helps a lot as well and bolsters it, and it gives you an extra area.
It allows you to explore your intuition faster.
Yeah.
It's easier and quicker for you to ask the computer a few questions than go down in the lab for 3 days. If you can say, what happens if I do this? And then it churns through an algorithm for 10 minutes, an hour, you're free to do something else. And you can ask another computer another set of questions. So it really allows you to explore all the nooks and crannies of your ideas and creativity.
It'd be great, actually, Max, if you can give us an example. I know many of the projects you're working on will be subject to confidentiality, but if there's a case study you could talk us through of where you've done that, where you've used simulation, and that's resulted in a new, improved, or a different product at the end of it.
Yeah, certainly. So it's interesting because we sit on this bridge, if you like, between medical devices and surgical tools and fast-moving consumer goods. If I was to give an example on medical devices, people might not be able to relate to it as often, as much as they could do. And that's our dream scenario, right? Because ideally people don't have exposure to any of the medical devices that we design, because that means that they don't require healthcare intervention. But what we do is, we spend a lot of time and effort making sure that those devices work first time, every time, all the time, for everyone, no matter where you use them, when you use them, how long they sat on the shelf for. So the ideal scenario is that all the stuff we do here, the average Joe, the majority of the population don't see any of that, which is great. But on the FMCG side of things, it's the opposite. Because these are products that people use and interact with day in, day out. I'm sure you've got a shampoo bottle in your bathroom. I'm sure you've got a bleach bottle under the sink. I'm sure you've got a deodorant can somewhere in your house. I'm sure you've got a moisturizer bottle somewhere. You might also have, an olive oil bottle, for example. All of these plastic products that are mass produced, there's a lot of engineering and design that goes into those.
Right.
And if we say, let's take a deodorant bottle, like a plastic deodorant bottle, for example, historically, that has been designed to be super stiff, super robust. Bomb-proof is the term that we often use. And what I mean by that is, if you were to drop it as you're unloading out of the car, or if it was to fall off the shelf, or if for some bizarre reason you were carrying it upstairs and it fell down on your foot and you kicked it against the wall, it's not going to break, it's not going to crack, and the contents are not going to leak everywhere. It's bomb-proof, it's robust, it's versatile, and it's designed that way because historically, we wanted things to be stiff. We wanted things to be strong. Now, more recently, there's been this push or this desire for lightweighting. And that, I think, has been driven by sustainability. People are becoming more aware of their environment. They're a bit more eco-friendly. And as a result of that, consumer product companies have listened and they're pushing to use less plastic per bottle. And you might see this across the supermarket in various different aisles.
Yes, they make big thing of it, don't they, often? So
for sure, yeah. It's seen as it's a good thing, right? Yeah. And some of them stick with plastic, which is great, and they use recycled plastic. Some of them pivot away from plastics. They might go to, say, cardboard or card.
Right.
Or they might even use a flexible plastic instead. But if we focus on an example where we're sticking with the rigid plastics, what you'll find is these products, these deodorant cans, these deodorant bottles, they are now becoming extremely optimized. They have thinner walls, they have less material, they have ribs strategically placed around the bottle to help reinforce it in specific areas that are going to make it more stable on the shelf, more comfortable to hold. It's going to be flexible where you need it, so you can squeeze that product out, but it's going to be rigid where you need it as well, so it's going to stay on the shelf. It's not going to crack as it gets transported there. If you decide to buy stuff online and get it shipped to your house, that e-commerce channel, again, is another bucket of challenges that those products need to go through. Now, we've all seen the delivery drivers arrive at our house and they drag that bag along the floor, pull it out of the van, and all your stuff's in there. You don't want the deodorant to crack and the shampoo or anything to leak out onto the rest of your stuff. So there's these competing requirements to use less material, to be stiff where it needs to and soft where it needs to as well. And to design those products, that's where simulation comes in.
Right.
That's where people can begin to say, if I take some material off here, if I move that material from over there to down here, if I make this a bit thinner there and a bit thicker there, how is it going to perform? How can I predict what's going to happen when I make these changes? And you begin to get this really optimized product where it's just enough material to do exactly what it needs to. And as a result of that process, there's a wide range of really fascinating and interesting things that happen as an engineer.
Yes.
Some of the ways in which the bottles fail, I find really fascinating. They no longer crack and break, they will buckle and flex. So the failure mode changes. And as an engineer, for me, that's really exciting. And when you draw parallels between what happens there in this super thin bottle with ribs, and now it changes to buckling as a failure mode, it's very similar to what you see if you're an aerospace engineer, if you design airplanes.
Okay.
Because those structures begin to fail in the same way. They're highly optimized. They have really, really thin walls, just enough material where they need to, and they have supporting ribs to provide stiffness and strength where it's required, but also flexibility where you need it to as well. So it's the same tools across different industries, used to solve similar problems, but it's just applied in a different context.
And do you find that sometimes the ability of those simulation tools means that the requirements become more complex? So you mentioned before, in simple terms, it was to be bomb-proof, so don't break when you drop it. Mm-hmm. Whereas now it may be don't do this under certain circumstances, or don't look less commercial because if it's buckled, it doesn't look as good on the shelf. Is that the case, that the requirements become stronger?
Absolutely, absolutely. People are not only wanting to use less, they're also asking more.
Right.
So since the pandemic, people have been more eager to order stuff online. Everyone got used to doing that. It was fine. It was convenient. But that wasn't what these products were originally designed for. The bomb-proof one's fine. They can take a kicking. But these newer, lightweighter versions of products, they weren't designed for that. So having these different ways in which the end user gets these products presents its own different challenges. And it can be a driving factor often, and these things compete. If you say you've got different shipping channels, how do you factor that in? If you've got different manufacturing plants, how do you factor that in? If you've got different consumer requirements from different cohorts, different demographics, so different geographic regions, is the US the same as Europe? Is Europe the same as Africa? Is Africa the same as Asia? All these consumers will have different preferences of what they want. And you need to be able to robustly identify and test how these products will perform in those different scenarios. What happens if you want a slight variant for the US market? I want to make it a bit softer, a bit thinner. Mm-hmm. You can use simulation as a tool to understand how is it going to perform if I take a bit of material off here, a bit of material off there. And that's really where we see value in using these tools, and the clients do as well, because you don't have to commit to making these products. You don't have to commit to making thousands of them. You can ask these questions quickly, virtually, and then have your answers within ideally minutes. But if the complexity is high, you can have them in a few hours.
So you could really help the marketeers, you could help the salespeople, you can take on board all their thoughts and requirements and help them test and try different versions of a product, I guess.
Yeah,
so it's not just driven by practicality; it's driven by commerciality as well.
Yeah, there's different facets to it as well. It's definitely more on the function rather than the form, but there's obviously those two complement each other. Mm-hmm. So there's wider reaching benefits from doing things virtually. You can pilot a few different things really, really quickly and get your answers faster, which I think, when you're thinking about spending money on a tool, which is where the investment comes in. So if you're going to commit to making a product, you're going to have to make that product like that for the next 5, 10, 15 years. And you really want to make sure that you've nailed that down. You've got that recipe for making that product perfect. And having all that information beforehand is really where the value comes in. If you've got to change anything afterwards, the time investment, the cost investment is astronomical. Yeah. And you've also got to explain to your customers why you've changed something. And we didn't realize this was going to happen, or this is a problem. So being able to future-proof your products in a virtual environment and test all these scenarios 10, 20, or tens of thousands of times, because it's cheap and effective, really helps you turn over every stone, look under every rock, and really see what could possibly happen under any scenario you can imagine.
I think you may have answered this question already, but I'm going to ask you directly. So from your point of view, Max, personally, what do you find so exciting about your work in simulation?
So I find the variety, if I'm honest, really exciting. I get asked this a few times, and I'm going to lean on an answer that I give because it's the same since I've joined here. It's the same. I get the same enjoyment, and I think it's always going to be like that. And this is an answer that I often tell graduates when they're applying for jobs. And they ask me, like, why Crux, why medical devices, why simulation? And historically, I was an aerospace engineer. I grew up with that as a kid, thinking that high tech was cool and fun, and high tech meant aerospace. Mm-hmm. And that's what I did. And I went off and lived that world, and I really wanted to live at the forefront of technology. I wanted to invent technology. I wanted to be on the cutting edge, and I had these visions of glass-walled labs and white lab coats and all these sorts of things. And for me, I thought that was turbine engines and spaceships and all these sorts of other things. That was where the tools of tomorrow were invented. Mm. Then I came here and started speaking to everyone, and I was like, what happens in the medical devices world? What happens there? I actually don't know anything about that. I think it was a very ignorant but also privileged position that I haven't been exposed to medical devices or surgical tools or anything in my childhood. And I was concerned that some of the challenges that I would be asked to deal with, or my clients would face and ask me to support on, or the team to support on, wouldn't be as cutting edge, they wouldn't be as high tech, they wouldn't be as complex. The tools that I would get to play with would be out of date, and the challenges wouldn't be as big. But since coming here, I am so happy that has been completely turned on its head. I get asked to do all sorts of crazy things all the time, and I use that in the context of supporting R&D projects, supporting due diligence activities, supporting root cause investigations with simulation as a tool to help solve those problems. And day in and day out, our clients come to us with some of the most creative problems. I don't know if you can say creative problem like that, but they're very creative in what they ask of their products. They are quite demanding. And as a result of that, there's a lot of technical challenge to overcome. Mm-hmm. And half the time I get asked to help support those projects, and I find that fascinating. So I don't know what's going to come in tomorrow. I don't know what's going to come in next week. And all I know is that I get excited when it's something I've never seen before, when it's something spicy and it's challenging. And I'll ask my colleagues, hey, what do you think about this? What do you think about that? And we have a good chat about it, and we're eventually like, oh yeah, that's a good challenge, that is. And it's having problems that come across your desk where you don't immediately go, that's the answer.
Oh right,
that's what's fun. Like it gets you thinking. It keeps you on your toes. And when I chat to some of my colleagues, we often joke around and say a confused day is a good day, because it means that we've got a good problem that we're trying to solve. We can't just look at it and say this is the answer. And we've got a reputation for answering some of the more challenging briefs that our clients have. Mm-hmm. Often they'll come to us because they're not sure they have the capability in-house, or they know that we have expertise internally and might be too much risk for them to take on, and outsourcing it allows us to de-risk that for them. But that also means that some of the spiciest challenges, some of the biggest questions, those are the projects that me and my colleagues get to deal with, and that's what I find so enjoyable.
Yeah, I can see that. And it's the spice, it's the challenge, it's making an impact, it's doing stuff that's not been done before, it's solving problems that may look very almost insoluble at first sight.
Exactly.
I have two more questions for you, Max. The next one, and you mentioned the fact that you're working on new tech, cutting edge ideas. Mm-hmm. So let's look forward a few years. What do you see as some of the things that the future holds for simulation, and what is Crux doing to stay ahead of the game, if you like?
Oh, yeah, that's a good one. So I think what's going to happen over the next few years or decades is the power of simulation is going to be put in the hands of people that don't have technical expertise. They're going to be able to access the benefits without having to go through the arduous training, if you like, that my colleagues have had to go through. And what that means is that all of a sudden there's going to be a deluge of opportunity for people to de-risk their designs early. So you might want to say, I'm only going to let engineers do the simulation. I don't want designers or other people to go into that realm because that's not their area of expertise. Absolutely fine. That's absolutely fine. And I think that's a very sensible way to look at it. But that skepticism is going to slowly dissolve over time. And what you're going to find is that as the tools develop, as they become easier to use, they become more intuitive, they are more foolproof, more and more people are going to have access to them. More and more people are going to want to use them. And as a product of that, they're going to need to be a bit smarter. They're going to need to think for themselves, if you like. They're going to need to be able to catch things out. Because they're not foolproof. They're algorithms on a computer at the end of the day. If you put like garbage in, you get garbage out.
Yes.
So and if you're not a trained expert, you might not be able to identify when there's something amiss. So what's going to need to happen is the software tools are going to become more and more intuitive. They're going to be able to coach people along. They're going to be able to guess what you need. And that's really where you start to see that now with AI coming in. And people are using these sorts of tools to help facilitate adoption of more complex ideas. So ChatGPT is a very convenient way of asking human language to a big model, a computer, and then it will regurgitate information back to you in a natural way. Simulation will be going down a similar trend where it's going to be made accessible to people that don't have this specialist technical understanding. They don't need to speak the language required to write the code or understand the physics. They just need to understand, this is my design, this is the shape. I need it to be able to go through this shipping channel. I need it not to crash. I need it to survive falling out of a car. Will it do that or not? And to get that answer, it's just going to be a very simple, really simple interface. So over time, what's going to happen is the way in which we interact with these tools is going to be really, really simplified. These clunky user interfaces that everyone uses are going to be dulled down. So imagine a bit like when the iPhone came out, everything suddenly became a lot more simpler, a lot more easier to use. I think things are going to go in that direction, and the use of AI is going to supercharge that and help accelerate the adoption of that in terms of non-technical users. What we do at Crux to help facilitate that is a wide range of different things. We often, what we describe as democratizing simulation, where we might take a pipeline, which could be the manufacturing of a bottle, like we talked about, manufacturing of anything. You manufacture it, then you test it in a wide range of different scenarios. Could be any of those conditions we talked around, falling off the shelf, falling out of a car, and then provides you with a quick and easy answer at the end. And we develop software packages to help demystify that process so that you can then deploy these tools to a much broader range of people within your company and really maximize the benefits of these tools without having this expert knowledge. You only need the knowledge to build them.
Yes.
And if you encase them in a nice user-friendly way, and a GUI, a graphical user interface, or a software package, anyone can start using them. And that's really where the trend is going to go.
But Crux, you can help make sure they're used in the right way and they're applied in the right way. This democratization, if you like, of these tools and techniques.
Absolutely.
Provide the context for it.
Yeah, absolutely. So we not only do the model build, the validation, the testing, the verification, all of that, we also wrap all that up in a nice user-friendly interface that anyone can operate with. Right. So it allows a much wider group of people to reap the benefits of the simulation.
Okay. Max, to finish, and thank you very much for talking us through simulation and what Crux does to be at the forefront of it. This is probably a very difficult question, but given all that we've talked about, what's the one key thing that you would like people to take away from our conversation?
Well, that's a very good question. I would say that simulation, the way we use it, it's not novel. It's been around for decades. And what we do here is bring those mature technologies into the medical device and consumer product space. So if you have a root cause analysis program that you need to supercharge, if you've got a due diligence activity that you need to de-risk, or if you've got an R&D pipeline that you need to accelerate, simulation can be the tool for you. The opportunities are there. You just need to go out and grab them. And at Crux, we're here and we're happy to help with those.
Fantastic, Max. Thank you very much for talking us through simulation, how it's used, and what makes Crux so good at doing it. Thank you very much. And thank you for joining us for this episode of the Crux Spotlight podcast series. Please do join us again for the next episode when we'll look at another aspect of what makes Crux such a leading product design agency.